You know, we have this picture of science as this nice, steady march forward, right? One discovery just neatly stacking on top of the last. But what if I told you the history of science is actually way more dramatic, full of these massive upheavals where entire worldviews get torn down and rebuilt from the ground up? Right? Is it really that simple? Just a straight line, always getting closer to some capital T truth? Well, turns out there was a thinker who blew that whole idea apart. He painted a far more chaotic and, frankly, a much more interesting picture of how knowledge actually moves forward. And that thinker was the American philosopher Thomas Kuhn. And his book from 1962, The Structure of Scientific Revolutions, wasn't just a big deal. It completely changed the game. He argued that science doesn't just inch forward. No, it takes these massive leaps, and sometimes it completely changes direction. So to really get what Kuhn is saying, you gotta toss out that image of a straight line. Instead, I want you to picture a cycle, almost like a life cycle that every big scientific idea seems to go through. He broke this whole cycle down into 4 stages. First, you have a long, pretty stable period he called normal science. Then, something weird pops up, an anomaly. This leads to a crisis, a period of total confusion, which can only be solved by a full-blown revolution. So, let's walk through this together. All right, let's kick things off where scientists spend most of their time, that long, calm period of normal science. This is the day-in, day-out grind of doing science, and all of it happens within the rules of something Kuhn called a paradigm. So what on earth is a paradigm? Well, the best way to think about it is like the operating system for a whole field of science. It's the accepted theories, the classic textbook examples, all the tools and methods, and even the unspoken rules that tell scientists, hey, this is a good question to ask, and this is what a real answer looks like. And Kuhn's own definition here is so important. A paradigm isn't just any old theory. It has to be such a huge breakthrough that it convinces a whole generation of scientists to jump on board. But, and this is the key part, it can't have all the answers. It has to be open-ended enough to leave a bunch of little problems for everyone else to solve. And solving those little problems is what Kuhn called puzzle solving. See, during normal science, scientists aren't trying to make some earth-shattering discovery that changes everything. They're just working within the rules of the paradigm, trying to make the existing pieces fit together more neatly. This puzzle solving usually takes 3 main forms. First, you've got scientists trying to nail down the important facts, the stuff the paradigm says matters. Then, you've got them trying to match those facts to the existing theory to get a tighter fit. And finally, they work on sharpening the theory itself, making it more precise, often with more complex math. Now, this all sounds really orderly and productive, right? But what happens when a scientist is working on a puzzle and the piece just won't fit? No matter how they turn it, it just doesn't belong. Well, this is where you start to see the first cracks in the foundation. And that brings us to stage 2 of our cycle, the anomaly. That one stubborn, awkward result that just makes no sense inside the world of the current paradigm. Now, an anomaly isn't just a simple screw-up in the lab. It's a result that keeps happening over and over, and it flatly contradicts what the paradigm says should happen. At first, the community might try to ignore it, sweep it under the rug as a mistake. But sometimes that anomaly just refuses to go away. So what happens when one anomaly gets joined by another, and then another? When they start piling up and become, as Kuhn said, intractable, well, you can't ignore them anymore. That shared sense of confidence starts to wobble, and the entire field enters a state of crisis. We have now hit the third, and honestly, the most chaotic stage of the whole cycle, crisis. And we're not just talking about a scientific problem at this point. This is a full-blown crisis of professional confidence. The rule book that everybody was following suddenly seems flawed. The very ground beneath their feet feels shaky. Kuhn said this is when the whole community feels like it's in disarray, like it's just falling apart because nobody believes in the old paradigm anymore. And this chart just shows the difference so clearly. Normal science is all about following the rules, confidently solving puzzles. But during a crisis, whoa, all bets are off. Scientists start doing what Kuhn called extraordinary research. They question everything, they'll try anything, and suddenly you get this explosion of wild, new, competing ideas. So this period of chaos, it can't last forever. Something has to give. The only way out of the crisis is when one of those new, wild ideas turns out to be so powerful that it doesn't just solve the old problems, it offers a totally new way of looking at the universe. And that moment, that's the revolution. And so, we arrive at the final, explosive stage of the cycle. A scientific revolution isn't just a little update. It's a total overthrow of the old guard. The old paradigm is out, a new one is in. This, my friends, is the paradigm shift. Kuhn put it perfectly with this quote. It's such a deep change that it's not just a new theory. In a very real sense, the scientists are operating in a different world. They're looking at the same things, but seeing something totally new. They're asking new questions, using a new language. This leads us to one of Kuhn's most radical, most mind-bending ideas: incommensurability. It basically means you can't measure the old and new paradigms with the same yardstick. It's like they're speaking different languages. You can't just compare them point for point because the very meaning of words like mass or space has completely changed. To try and make this idea a little easier to grab onto, Kuhn used this brilliant analogy from biology. He said, a revolution is like speciation. When one species evolves into something brand new. The old science doesn't just get an upgrade, it becomes a new thing entirely, something that can't breed with what came before it. Okay, so hold on. If old paradigms just get thrown out and you can't even really compare them to the new ones, then what happens to our idea of scientific progress? Are we actually getting closer to the truth? Well, Kuhn had a fascinating answer for this. He said, yes, of course science progresses, but not in the way we usually think. It's not progress towards some final finish line called the truth. Instead, it's progress away from a system that just isn't working anymore. Each new paradigm is just better at solving the problems that scientists are dealing with right now. And that leaves us with a really big, kind of scary final thought. If science moves in these lurches from one worldview to another, and if progress just means getting better at solving today's problems, then what does that mean for all the scientific knowledge we're so sure about today?